be true of Java. There's about 78 billion different libraries for doing file I/O in Java. And the book will show you like 2 of them, so those are the 2 you have to learn for the class, but then there are plenty more. And they all are subtly different. You know, some of them buffer the output before they write it, some of them don't. Some of them write things out as binary data, some of them write them out as text data. The one we're going to do here writes stuff out, I want to say as text data, but I may be wrong about that. We'll find out. We'll open up the file that we create with a text editor and see if we can read it all. So why do you use files in the first place? You use files in order to give your program input or as a way of saving your output. Allowing your program, your data to be retained between program runs. If you type in your thesis paper and it never saved a disk and you turned Word off and you had to type it back in to make a change, that'd be really annoying. So, yeah. Even in the early 70s, people were starting to make typewriters with memory. So you could type an entire page in, and then you could press the button and it would print that page out again. That's like before word processing. What if you had to make a change to it? Well, too bad. You had to type the entire page in again. So, steps. You generally open the file, you use the file, you read from it, you write to it, or maybe both. If it's a random access file that lets you move, you know, the cursor around conceptually in the file and do both. We're not going to do random access files. Instead, we're just going to read sequentially or write sequentially. And then you close the file. If you do not close the file remains locked for writing or whatever, meaning that if you try to copy that file and paste it into another directory, or you try to move that file, the operating system is likely to tell you that the file is in use. So in some cases, it's useful to lock the file. You know, somebody's got a Word file, a Word document open, probably ought to remain locked the entire time to prevent somebody else from opening it and making changes at the same time. But if you're just doing like creating a backup file, you know, you don't want to keep that file open because then the backup program might not be able to save it, you know. Or if another user goes and copies, you know, the directory and pastes it into a backup directory, they're not going to be able to access it. So in general, you want to close the file as soon as possible. So what is needed? The way we're going to do this is with file streams. We've already heard the word stream before. Stream is for cout and cin. Well, with the file stream class, the IfStream class, in order to write to a file, we still get to use our less than symbols, our arrows. And in order to read from the file, we still get to use greater than. So, once you have created a file stream for writing, you can just go and replace all your couts with the name of the file stream. And then your code is already writing its output to a file. So if the types, IfStream is input, OFStream is output, FStream is for both. So define file stream objects.
When you say both, is it only for read-write objects, or is it, and then like the input is just for like writing objects?
Let's go find an example of FStream because honestly, or maybe it's in the PowerPoint and I just don't remember it.
Can you use it interchangeably with like IfStream and UpStream?
That's what I'm wondering. FStream is an input-output class. We want to find the member functions of it. Open, close, get a buffer, peek, look ahead, read. I like this command, read sum. Put back, you've read something, but now you want to put it back into the file. Ungit, I like that one.
Because of the name.
Yeah, I got the data, now I'm going to ungit it. I'm not sure the difference between put back and ungetting. So the answer, I don't have a good answer for that class because I really don't know what FStream is used for. Whenever I did C programming, I did a byte-oriented version of file I/O, which was not using the stream operator. And that is far closer to the way that you do it in Java and other languages. So I learned the I/O stream in order to teach it. Maybe the PowerPoint has IfStream, hopefully. Otherwise, I'll do some reading and I'll have a better answer next time. Okay, this statement is just showing how to define, how to declare. I would not use define. Maybe they use define everywhere. To me, that's a declaration. We have declared two variables now with those two statements. Do you have to call them in file or out file? No. You could just call it in and out, whatever. So opening a file creates a link between the file name on, well, that's a silly thing, but using the computer's I/O calls, a link is established between a space on the disk and the file stream object inside the program. So you open it like that. I want to open an in file, input file, and I'm going to, that's the file name that I want, and the operating system will serve it up. And if you specify a path, you know, dot backslash or, you know, C colon whatever, then it'll accept those as well. So the file name may include the drive info or path info. If you do this, outFile.open, if the file exists, it will be erased. If the file does not exist, then it creates it. If you use IfStream, I do not believe that to be the case. You can preserve the file that is already there. In order to open an input file, if the file doesn't exist, you get an error. How could you open a file that doesn't exist? Once you get the file open, there are different ways of testing to see if it worked. This is the way that the book shows. And it looks kind of weird to me. And it doesn't look compatible with other languages, but it's how the book shows it. So there are also functions to test to see whether the file has been opened correctly. And I'd rather use functions like if infile.error is equal to true or something like that. I forget the function. But this is what we're going to go with. We try to open the file. If the file was opened, then this would be false, not in file. Not in file evaluates to true, you know. If the file was opened successfully, then in file is equal to true. Not really, but in this case it looks like it. And if the file was not opened successfully, then not in file would be set to true.
Is this essentially like the line of thinking that Word goes through when you go to open a document or something?
Right.
Okay.
Right. You should always test to make sure that you got the file open. There are different things that can cause a file to not be opened. If you're reading it for input, if the file doesn't exist, then it won't be able to be opened. If you're writing for output, when might the file not be able to be opened? Yeah, if somebody else has it locked for opening, or if you write to a drive that doesn't exist, you know, z:\my file, and you don't have a drive, a Z drive. You can also use the fail member function. I would rather do that, honestly. I would rather write this, if infile.fail, like that. That looks better to me. Either way works. Using files. Once you get a file open, if it's an output file, you can use that arrow. If it's an input file, you can use that. Greater than, its technical name for it is a string extraction operator. It returns true when a value is successfully read and false otherwise. So you can use that to test to see if the read actually worked. You can do if and then embed your data reading command in there inside your if, or while and embed your data reading command in there. Why are you going to do that? Because you want to read to the end of the file. And that's one way to test to see if you got to the end of the file, is that if this ever failed, it meant that there was no more data in the file. And so it's time to stop reading from it. All right, one more slide, and then we are going to actually write some code. Use the close member function. Don't wait for the operating system to close the file. Once your program exits, the file will get closed. But that means that you've hit the end of main or something like that, you know, and if you had that pause command or something, then the file is waiting there until, you know, you actually close the window or hit enter. There may be a limit on the number of open files. Back in the old days, systems had limited resources. If you're a Windows 3 programmer, you were always getting these out-of-handle errors because there were only 255 different objects, and each file that you had open was a handle, and each window that you were drawing was a handle. You could very quickly run out of handles.
When was Windows 3?
That would have been like 1989. Programming Windows 3 was hard because you didn't have all the cool libraries that you have now for creating graphical user interfaces. It was like one step up above from doing assembly. Alrighty, you can ask the user for the name of the file and store it in a string. And then as of 2011, you can pass the string object as an argument to the file stream object's open member function. I kind of wonder how it was before that, because C++ has been around since, you know, the mid-80s. How did you specify the name? Probably as a character array, an array of characters rather than a string. All right, let's do some file I/O-ing. So along with IOStream, we're going to need IfStream. And we may as well get string as well, just because I always feel comfortable bringing the string class in. The reason for that is there already is a string class that comes in by default with C++, but it doesn't do near as much. And so if you're expecting it to be able to do all the cool things that we'd like to do with strings, but you left the include string out, then it will look at first like the code's working, but then you're going to try to rely on something and it's not. To me, that makes it sound like they need to make that string class part of the default C++, but I guess it would probably break old code that was written before that string class. New item, add a C file. We need an IOStream, so # include IOStream, # include IfStream, and then good old string, # include string. Do we feel like being macho and skipping the using namespace today? I'm going to go ahead and do using namespace. A fun thing to do is to take that out after you write the program, and then you just have to go through and add std : throughout it. Int main, I'm going to put my pause at the bottom. System, parentheses, quote, pause, and then put a return 0.
And I know you said that it just, well, what does it really do with what it returns if you do really want it to return anything? Like, where does that go? Is it just out memory?
Well, it doesn't really use up much memory. It gets returned back to the program that ran the executable. So since Visual Studio is running these programs, Visual Studio should know what was returned. What it was used for is you could do this, and I'm probably going to botch it because it's been a long time since I've written bat files or stuff that rely on it. But you could do something like this. A is equal to print my file. This is inside the bat file. And then you could check to see if A failed. If A, is not equal to 0, that means you got an error code. And so you could echo out an error code. File did not run. Print did not run. So you could embed the calls to your executable, print.exe. You wouldn't even use print this, like that. And then you could print error messages if it didn't work. So it gets stored, it gets passed back to the calling. And the calling program, when we run it like this, is Visual Studio. If you were running it from Explorer, by double-clicking on it, it gets passed back to Explorer to be ignored. If you ran it from the command prompt, it gets ignored, but if you ran it from a CMD file or a BAT file, you could check that return value.
And it always just, so every function or method, they need to return a value, but it doesn't have to be a name, right? It doesn't have to be.
If you define it as void, it doesn't have to return anything.
Oh, so
Now main is supposed to be defined as an int according to the standard. But everything else, if I wanted to do this, void.
What is a void?
Void means no return value. So see, if I do this, int yum return 3, then when I call yum, I can store its value. Int x is equal to yum. And so it'll come up here, it'll run that, it'll return 3, and after this line of code executes, x will equal 3. But if I do this, void yuck, then I can't return anything. What it's going to do, I don't know. It's going to say yuck. So down here, when I call it, I can't store its return value. I can't do x is equal to yuck. It's not returning anything to store in there. So a void function is one that does not pass a value back. Some textbooks say that this is a fruitful function because it returns something.
I just always wondered that because, like, you know, in Java, the main function is void, but...
Right, because Java does not allow you to pass a value back to the operating system, because Java is running inside its own application. It's running inside the Java virtual machine.
Oh, okay. So executables are just ran from the operating system?
Yeah,
Okay.
right.
Makes sense.
Yeah, there's no layer to run an executable between your program and the operating system as long as it's for the operating system that it was written for. If you run an executable on a Mac, you better have the software that'll run Windows programs on it. All right, let's create a file. I don't want to botch it, so I'm going to go back and look to see how they did it. Exactly. Here's how you declare. Let's open a file for writing first. We're going to write a file, close it, and then read a file. Let's ask the user for the file name, just because it's fun to be able to specify different files. So let's make a string called file name. Let's ask write to what file name, and let's read in using CIN into file name. Then we actually need to create that object, that file object. Since we're writing output, we're going to use IfStream. So IfStream, and I'm going to go ahead and just call it out rather than out file. It's shorter. And then we use an open command. Out file.open, and we're going to open our file name. Excuse me, why did I make it out? Yeah, I'm probably going to do that through the whole program. Out.open file name. Now we need to see if it failed or not, or if it worked or not. You know, you could test for either condition. Here's how we could see if it failed. One way. If out.fail, like that, that's one way. Cout file could not be opened. It'd be nice to echo the file name as well. So I'm going to go ahead and write the file name out as well. Why? So that, you know, if I made a typo in it, I get to see immediately that I made a typo. Now I could embed a return statement right there, you know, kick us out of the function entirely. And then I wouldn't have to use an else like I'm just about to do. But I'm not going to kick us out of the function entirely. I'm going to use an else. If we get here, the file worked successfully. Here's how the book shows to make this test. They do if not out. They replace out.fail with if not out. Just pick one that you like. I like that one. To me, that's a lot clearer. But I guess that's Maybe a Java programmer's preference. Alrighty, we've got our file open now. This created a file. Out, arrow, arrow. This is my first file. Cout. My name is Jeff, and I am cout. Type in a number rather than a string. 8 space years old. I don't want to write the 8 out as a number, as a string, because I want to go and open this file as a text file and see if it's saved as some sort of binary data or if it's saved as text, as ASCII text. Then let's write an end of ENDL there, and we're going to call that done. We have created a file. Let's close our file. Out.close. I guess you could argue that if the file wasn't open to begin with, you don't need to call close, but it's not going to blow it up if you call close on a file that's already been closed. I say that, I hope it's true. Okay, I've made a serious mistake here. Can you spot it? I'm going to highlight the 3 lines that are in error. It's supposed to be out, not cout, because I'm trying to save this data to a file. It would print these lines to the screen rather than saving it to a file because I did cout. Burp, burp, burp. But you see how easy it is to change a program from displaying data to the screen to displaying it to a file if all you have to do is change the variable in front of the stream insertion operators. Of course, you have to open the file first. Close it at the end. Alright, write to what file name? I'm going to try to give this an easy one to find. I'm going to call it myout.txt. You can call your file whatever you want. I called it txt so I can double click on it and open it with Notepad.
I got it says non-standard syntax. Use and to create a pointer to number.
Alright, let me come look. Version of Visual Studio you're running here? Using 2013 here or a different one?
17.
17, okay. Could be a difference. What version of Visual Studio did you install?
I have 17. Oh wait, I think I figured out where mine is messing up at. Check your, double click it, double click the error.
I found it.
And it's, yeah, should highlight it.
So what was the problem?
My fail. You know.
Oh,
since it's a
out.fail
function,
is a function.
I see that.
Yeah, I had like one too many parentheses.
Okay.
Brackets up there, that's all.
Okay, I thought I was complaining when y'all were describing a problem about the 8. Teach me. All right, I ran it. It supposedly created a file. I need to go find it. It should be saved in the project folder because I did not specify a path. So C++ projects, I need to find my newest project folder.
Can you just search for it?
I could search for it. And there it is. It's in my project folder, myout.txt. I'm going to open it up. And it did save the entire thing as text, even the number. And what do I mean by that? We've already talked about ASCII, right?
Yep.
In ASCII, an 8 is a...
Oh, that's cool. That's super cool that it worked like that.
An 8 is a saved as a 56. So if we go and we look at the bytes for this, it's a series of ASCII values, and that one is a 56. But we know from doing our conversion that an 8 in binary is certainly not 56. What is it? If we had to take the number 8 in either hex or decimal, because it would work, and I asked you to convert it to binary.
0100.
Right, it'd be, no, 1000, 8421. So, which is an 8. So when your program is being read, if it found an 8 and it was trying to read binary data, it would know that that was an 8. If it read this as binary data, it would treat it as a 56. But this is ASCII text, so when it hits the 8, it's going to be a 56, but it gets turned into the character 8. I don't know if that makes sense or not, but if you're storing binary data, you're not going to be able to open the file with Notepad.
Essentially doing ASCII, that's the reason you can open it.
Right, it's creating ASCII text, which is good because that's the same kind of text that gets displayed on the screen and what you type in with your keyboard. Okay, now we're going to write some code that will open that file and read it to the screen. So instead of using IfStream, we're going to use IfStream because it's going to be an input file.
It'll read it to our CLI.
Yeah, we're going to read in a line and we're going to send it to cout. Exactly.
All right.
So do we need like a string read line or something?
Not quite.
Store it in and-
It's going to look a lot like this. While, I mean, don't type this yet. While in can be read into text like that. And then we're going to have a line that looks like this. Cout text. It's going to look a lot like that. And again, C++ is a pretty weird beast. You're not going to see that in your Java class. Plus is very the stream insertion operators are very idiosyncratic. I've only seen them in C++. All right, did you get it to run, or is it still compiling on you? Taking a while to process this.
So we could create a file anywhere using this.
Yeah, you can
But
specify any
any
directory,
needs
but
to.
some directories are protected by the operating system.
Oh, okay.
Yeah.
And, okay. In case of like a virus or something like that?
Yeah,
or-
yeah. So hopefully the C:" Windows directory structure is read-only. We should not be able to write to it without elevated privileges. Now, almost everybody creates their own home computer with an admin account and just uses the admin account. So yeah, you could write to anywhere anyways. But if it pops up, with that window, UAC, warning, do you really wish to do this? And you have to click yes or type in your password again and stuff. You're trying to write something that was, access something that you shouldn't have.
But then again, like you said, most people do the admin thing, and
You're right.
those people probably aren't gonna be like, they're probably just like, yeah, I do want to do this.
Right.
you know?
Right. All right. I'm going to print a copy of this out, so if anybody needs it, because we're going to move on. We have a IfStream for output, but now we're going to use an IfStream. IfStream, I'm just going to call it in. Textbook uses in file. Let's ask them again for the file name. I'm just going to copy this statement, write to what file name and CIN what file name. Copy, copy. Grab those two and paste them. But I better change it to read from what file name to let them know what we're doing. We could just use the same file name, but I think it's more fun if we ask for it. So we've got IfStream space in, cout, read from what file name. We let them type it in. Now we need to open that file. in.open, and we pass in that file name.
Then do we set up the same failure code? Like if it doesn't read, then
Yep. Then you need the error, the failure code. If in.fail, print out an error message. If parentheses in.fail, don't forget your function call parentheses. Could not open file, and then I'm going to go ahead and print the file name. Else. Now we're going to read with a while loop. While in, we need a variable in order to store our text data. So string space text, and then while in arrow arrow into string. Nope, into text. As long as we can do that, and the syntax looks weird. I finally just gave up and accepted it. Then let's write that text out. See out the text we just read. Then we want to close our file. in.close. And you'll find this is true also of Java, but the way these file functions are written, a lot of them will let you interchange sockets, internet sockets, with files. So if you want to send data over the internet in C++, it ought to be possible to do the same thing with the arrow syntax.
so instead of a file name, we'll just input a URL or something.
A URL, a machine name. Well, you'll have to open it first. The open syntax would be different than this, you know, but put in a machine name and a socket number and
You need a machine name, like you have to know the
a web address. I mean, a URL would probably work as long as it can
You have to have
resolve it. I don't know if you have to have the IP address. I don't recall anymore. I don't think so. The libraries ought to be smart enough to be able to query the domain name server to get the IP address. But you specify, you know, a URL and a socket number, and it'll establish a connection to that socket. You know how when we are accessing a server, like wow, if I go to lumland.com, what happens is my browser makes a request of lumland.com, and it says give me some data, and it feeds it back. It uses the HTTP socket. So that means that there's server software on that machine that's listening, waiting for connections, and it's like you have a whole bunch of different faucets, a whole bunch of different pipes sticking out of a building. And if you want to get HTTP data, you better plug into that one. But there's other kinds of data. There's FTP data for file transfer, and that's a different socket. So it'd be like hooking up to a different spigot on a house, a different pipe on a house. And voice over IP uses another socket. So if we go out and look, common sockets, IP, maybe that'll work. List of TCP, okay. I'm using the wrong word. Port is the correct term. Sorry about that. They're ports. Socket is a Unix term. Same idea though. If you're going to do,
So sockets is just like a Linux thing.
yeah, Berkeley Unix is probably also in Linux. I bet that versions of it have been written for all the different operating systems, but in internet terms, the correct term is port. So where's the HTTP port? Whenever your browser makes a request, it opens port 80. Right. When it makes an FTP request, there's different port numbers. You can see that socket numbers can get really large. Why? Because there's a whole bunch of protocols out there.
What? Oh, so those are just the different slots in that server?
Right, right. Different conceptual slots.
Can multiple computers occupy the same slot then?
No,
So like.
I shouldn't say that.
We both go to the same website at the same time. We both access the HTTP port.
Right.
But
But that the server software can
It's only
open.
coming out one at a time.
Right. The server software can accept connections on any sockets, and it can accept multiple connections to the same socket, which seems weird, but just like you can park multiple cars in a driveway, you can have multiple sockets open. I could open channel 80 at the same time as you can, as long as that server software knows that, okay, IP address 13 has this socket 80 open, and IP address 14 has this socket open. And so when I make a request, it sends data back through this socket, and when you make a request, it sends data back to that socket. Weird concept, perhaps.
No, I mean, that's how that server recognizes the individual computers.
Exactly, right. So, if you go out to the command prompt, I think you can type IfStat. No. List of open ports on Windows. You probably just told me what it was. Netstat. So open a command prompt, type Netstat, and you get a list of all the ports and IP addresses that your machine has currently established a connection to. And sometimes you'll wonder, why does it have all of those open?
How did you open the command line?
I went down to start and I typed CMD. Or you can hit Windows R, you know, the Windows key, to do a run.
So when you do that IP config, IP renew stuff, does it shut down all those ports and those ports right there?
If you do an IP reset,
Renew, usually it's IP renew. I think it is.
yeah, I'm not an operating system guru. You actually probably know more about it than I do. But yeah, you can wipe your IP configuration, and I would imagine it would close all the currently running.
So what does the Netstat tell you then? It's just where you've been to on the internet?
Not where you've been, all the currently open.
Oh, it's where you're at.
Right. This is our local address. As far as our internet is concerned, I'm on 10.130. You should have a different address. And here's the foreign address exposed as a name. There's a version of Netstat. You can ask it for the IP addresses rather than maybe it's -n. Netstat -n. Yeah. Now we can see the IP addresses rather than the names. So we look up here, what all do we have open? We have several connections to Microsoft for some reason. Venus is probably our own server. Which one was that? On port 6420. I don't know. Let's go find out what port 6420 is. Port 6420. That's higher than ports are usually defined.
Oh wait, I also forget. Well, if it's our port, they can choose.
They can choose whatever they
so
want,
that's
right.
probably what they did.
Right. And if you want to specify a different port, you could make a server that instead of listening to port 80 for HTTP requests, it was listening to port, 6700, whatever. And you would do that to make it more difficult for other people to access that port.
Just a security protocol.
Yeah, yeah. Now, we don't have anything listening on that. Oh, Wikipedia accepted it anyways. No, it didn't. Anyways, but you can specify it. I may not have the correct syntax. Let's go back to where we were. We have our file open. We are reading from our file. And then we close our file. And I'm just going to print a done message so that we're all happy. Alright, I'm going to write to what file name? t.txt. Supposedly it wrote to it. We don't know. We didn't get a confirmation message. That's just because I didn't put one in my code. Now read from what file name? t.txt. This is what's in the file. This is my first file. My name is Jeff and I'm 8 years old. Done. Guess what it's doing? Why is it all squished together like that?
Is it not reading white space?
Right. We're not using get line.
Yeah, okay, that's what I was gonna say. Cause get line.
So we can't quite do it that way if we want to read in entire sentences at the same time.
So what happens if you run this program multiple times and the part where it asks where you would like to write that information, is it going to override if you...
It will overwrite. The open command, if it's an IfStream, erases the existing file rather than append to it.
What if you don't specify a file type? What time will it save it as?
If you just make it an FStream.
If you just don't give it a suffix opening, you just write.
The operating system doesn't care. It writes the same file format. The operating system uses that file extension to hook it up to a program. So you won't be able to open it by double clicking it if it doesn't have a file extension.
Specify the file format.
Right, but you could still go into Notepad and do file open, see all files, and open it that way.
Okay.
Yeah.
Open with this program or whatever.
Alrighty. I don't know if I want to figure out how to get that to work.
Did it say I think it said fn.getLine.
Yeah.
So if you did that, would it work?
Let's go here and see if they mention get line. Yeah, of course not. Alrighty. Alright, at this point I'm experimenting. I'm just not thinking that this is going to work. That's pretty nasty looking. This is defining a character array and passing it in. Let's see if we can pass in a string and a number of characters to read. So text, comma, 80. Is that good enough? Nah, we're not going to mess with getLine. Now I'm not going to undo all that, but let's write a program that's going to write it like a series of test scores out or something like that. I really need to undo that. What that's going to look like is something like this. You know, you open the file. Out.open, you give it a file name. Scores.txt. And then you could have some kind of loop. Ask the user what the score is. What is the score, or -1 to stop. Then you would read that in. Double score, CIN into that score, and you could write it out to your file. Write that score back out to the file, like that. But you would need to make sure that they hadn't entered a -1. So after you read in the score, if score is equal to -1, then break. Then you'd want to close your file. It'll be interesting to see what this one looks like, because I'm not putting spaces between the scores. Is it going to automatically put spaces between the scores? We will find out. There were build errors. Probably that stuff I was mucking with earlier. Oh, I still have the application running in a window. So, score 190, 80, -1. I want to go find that scores.txt program now, see what it looks like.
Yeah, it just puts them all together.
So that's not perfect. I could put them one per line, or I could put spaces between them. I'd probably choose to put them one per line. So I should be writing E and DL out after each one. Just like you would have to do on screen. That makes sense. Okay, so I just changed that line there. File again. Don't know why I keep closing that directory.
Yep.
Alright, there's my scores. I had entered 3 of them and it wrote them out.
Oh, I just broke my program. My executable is like, it just keeps going.
Let me come look.
Okay.
Alright, and for those playing along at home, I accidentally stopped. Forgot to restart the recorder. So, let me pull this up. This is the code that creates the scores file. Or from here, I need to put some comments here. From here down to here, pause your recording, type it in. Now let's read the file in. that goes from here down to here. Pause that screen and type it in. All right, I'm going to run it, see what it does. This gets tedious. T.txt, T.txt. What is the score? 100, 90, 80, 70.5, -1. And then it read those 4 scores in. So the evolution of this program would obviously be to modify it to average those scores together. Alright, anybody getting syntax errors? So wasn't our last program a kind of loop where you read in, where we wrote, where we typed in the rainfall for 12 days? Okay, so here's what our homework is going to be. One, modify the BMR program to save its output to a file. So you're going to open the file and you're going to, if you want to copy and paste all those couts, or if you just want to write to the file and not even display it on screen, that's fine. And then 2, modify your rain program to save each value to a file called rain.txt. When the user is done entering data, close that file, open it as an IfStream, read in each value, calculating the average. So it's going to be a fair bit of modification to your rain program in order to do that. But this is obviously is going to be pretty easy. Just change your BMR program, ask the user for a file name, ask the user for the file name, and use IfStream. So that'll be the homework based on that. Anybody need a break, or can we just keep charging? Feel free to say we need to stop. Your bladder may be suffering. Okay. May need to stretch your legs. Alrighty. So, testing for file open errors. Yeah, let's go ahead and break. I think we ought to. I insist that we get that to look better. So that was up here. Read from what file name. And then we use this. While we could read text, write it out. But it's reading it in word by word rather than line by line. So what could we do to make it more readable?
See out, and then, well, what is text exactly?
Text is just contains a single word.
So could we? Could we
Well,
just
if-
see out text and then put a space?
But put a space, yeah. Let's do that. All right, this is my first file. My name is Jeff. My name is Inigo Montoya. And I am 8 years old. Done. Okay, so it didn't preserve any, line feeds or anything like that. But that's the best that we're going to be able to do using this kind of thing, which reads in, which tokenizes it based on white space.
I did an end line after the space.
Rather than it'd write it all the way. Yeah, yeah. If you put an ENDL there
Line
instead,
for each word.
it'll, yeah. There we go. Works either way. So using files. Use the output file object and arrow to send data to the file. Output inventory report. Use the input file object to copy data from the file into variables. In file into part number. In file into quantity and stock. Here they're reading in 2 pieces of data with 1 in file call. Using loops to process files. We were doing this. The extreme extraction operator, arrow, returns true if something is read, false otherwise, and we use that in our while loop. So it can be tested in a while loop to continue execution as long as data is being read. So what's happening is each time that this happens, if number does get filled up with data, that is true. But if number fails to get any data, then this evaluates to false. And honestly, looking at it, I don't know how that happens, but it does. And then closing files. Don't wait for the operating system to close the files at the end. There may be a limit on the number of open files. There may be buffered output waiting to send to the file. Okay, let's find out how, if there are any other operands for .open. I mean, here's the IfStream .open, so I'm going to highlight that word and press F1. If you're using Visual Studio, that should bring up a help page. Parameters, you can pass in a file name, you can pass in an open mode, and you can pass in the default file opening protection. Let's see what open mode is. That's odd. So you could use binary to write the file or read the file as a binary stream rather than a text stream. Let's go back here. Not really seeing anything fascinating there. Be interesting to play with the binary version of it. Let's go look at the, yeah, so if that is the open mode is iOS based : out. And what other open modes were there? So since this is I guess if we were just opening it as an F stream rather than an OF stream, we would get to specify, or we would have to specify whether we were opening it for read or write. And tacking that on would open it for output. Are there other things that IO base can do? That we just pulled up. way, way, way more than I could possibly comprehend. So, we cheat. Open IfStream for binary mode. C++ binary file I/O. The basic model for file I/O. C++ are designed with the idea that a file should be viewed as a stream or an array of uninterpreted bytes. So to do binary, it's possible that we may have to talk about arrays first. For convenience, the array of bytes stored in a file is indexed from 0 to length -1, where length is the total number of bytes in the file. The current reading position, which is the index of the next byte, okay, getting the size of the file. If you want, you can get the size of a file by using something inside of sys, by using something inside of a header file called stat.h. You could use that to see if the file exists before you even try to open it. You know, if this fails, or if the file size is 0, then it means it's not a readable file. So here we go. If we want to open a file and we want to save it as binary, we would use that flag. Let's give that a shot. Let's change our program to use these flags, just to see what happens. Go back in to this thing that says write to what file name, and add this to it. Change your out.open line to have this stuff. ios::out, it's an output file, which we knew, and an ios::binary, meaning that we're not going to save it as ASCII text. It did not behave differently. Perhaps because we were still writing ASCII text out to it. Can't see that it did a ding bit of difference. We're going to skip the idea of binary files versus ASCII text for now, until we've learned about arrays. Arrays may be the very next thing we talk about, because I don't know that there's anything else in this PowerPoint we need to talk about. Using the CString member function for older versions of C++. If you're not using Visual Studio, the open member requires that you pass the name of it as a null terminated string. A null terminated string is an array of characters where the last character is a 0, a null. So string objects have a function which will return a C string, a null terminated string. So if we were writing this for an older version, and I had somebody do this, they had installed a different C++ environment rather than Visual Studio, and then the open call was failing, and we had to add this to their code. All right, breaking and continuing a loop. Now we're back to loops. We've talked about this though. You can use break to terminate execution of a loop. And guys, I'm sorry that we kind of got meandering there. Let's focus back on it now. Use breaks sparingly if at all, because breaks make code harder to understand and debug. I'm of the opinion that used in while true loops, it's okay. Otherwise, probably not. When used in an inner loop, it terminates that loop only and goes back to the outer loop. So if you have code that looks like this, while x is less than 100, and then you have another loop while y is less than x, if you put a break here, it only exits this loop. It would go to here. Because if it bailed out of that one and went down here, that'd be really annoying. In Java, and I know some of y'all are tired of me saying this, you can specify a position. You can give a name to a loop, and then you can tell it which loop you're breaking. So you could say, okay, am I breaking out of loop A, or am I breaking out of loop B? And I'm curious as to whether I can do that here. I'm going to give it a real quick shot. I'm going to go into Visual Studio, and I'm going to tack that code on to the very end of my program. X is equal to 0. While X is less than 100, I need to declare some variables. Int Y is equal to 0. While Y is equal to X, let's add 1 to Y there. Let's add 1 to X here. Now I know what that's going to do. It's not going to be very useful because it's just going to, it's not even printing anything. What I'm wondering is if we can give these loops names. Can I say this is my Bob loop? And can I say that this is my Fred loop? And then I could say, okay, I don't want to break Fred, I want to break out of Bob. Nope, that didn't work. These are called labels. We have actually labeled our code. Back in olden days, you could use goto Bob to get it to go back to where we were, to a label. Goto may still be supported in C++ for all I know, but it's considered extraordinarily bad program to use goto. What that would do is it would run all this stuff, and then when it finally gets here, it would jump and go back to here. And it would do it all again, and it would never stop doing it. Using goto leads to what's known as spaghetti code, where it's impossible to visually inspect your code and figure out the logic that it's going through. So goto is bad.
In that case, I think everything
What was the
spaghetti
point
code.
of it initially then?
Well, it predated a lot of other things. Like, you could do this. Top of loop. We're going to have a label there. So X is equal to 0. Top of loop. Print X, X plus plus, if X is greater than or equal to 100, go to top of loop, like that. Now you've implemented looping without a while statement.
Okay. And it's going to be essentially a counter then.
Yeah. In this case, we have a counter. It's going up to 100, but we've implemented it without using a while statement. And
so what happens once it reaches 100?
It would go to whatever's here. Print, I'm done.
Okay.
So gotos were part of the assembler programming language. And then things like BASIC implemented it. And there was no while command in assembly because assembly is just a list of commands, you know, a list of opcodes that are being fed to a processor. And so the early languages did support goto, but then once you had more complicated programming structures like for loops and while loops and stuff like that, then it was deprecated, meaning recommended against. So here's a question on Stack Overflow. Can I use break with a label to exit multiple nested loops? And it says C++ does not, but Java does. All right. So continue. We didn't talk about continue. This is new information. for those who are looking away. What continue does is, you may have seen it in other languages.
Oh,
though.
yeah.
It bops it back up to the top of the loop. So if you have this loop, if x is less than 100, C out x. If x is equal to 50, continue. And this is really badly written. Let me change it to something that would actually do something interesting. Let's print even numbers only. And this is a stupid way to print even numbers only. So if x percent 2 is equal to 0, then continue. So what happens? We're coming in here. X is equal to 0. Is x less than 100? It sure is. Add 1 to it. Okay, now x is 1. Is x even?
No.
This is actually going to print all odd numbers rather than even. So that's not true. So it's going to print out x. And it's going to come back up here. Is 1 less than 100? It sure is. Add 1 to it. Now it's 2. Is it even? It sure is. Continue jumps it back up here before it hits the C out statement. So this code would print 1, 3, 5, 7, 9, and so on. I don't use that very often. Why? Because you can do the same thing with if statements, right? This could just be if whatever and then put, some stuff in here else, C out. You could rewrite it so it didn't use the continue. But I'm sure there are times when it's useful. Let's see what their example is, if they any have. Use sparingly, like break, it can make the program logic hard to follow. And that's the end of that chapter. All right, we're going to talk about arrays one little bit. And then we're going to call the turkey done for today. So the way you define an array is you use square braces. I'm going to make an array of 10 integers. And I want them all to have the value of 0. That initializes the entire array to 0. So if I do this for int x is equal, no, my array, I'm going to call this AX for array x. Now I need a counter. For int I is equal to 0, this is going to be my index. While I is less than 10, add I to it each time. And then C out the array element at that, followed by an ENDL. It should print 0, 0, 0, 0, 0, 0, 0, 0, 0, and so on. I'm going to move this code up to the top of my test code because I've added all sorts of gunk to the bottom. That'll probably stop it from even running. So it wrote out zeros. But I can stick other numbers in here. For example, let's copy the numbers 8675309 into it. And the first position is going to be an 8. The second position in it is going to be a 6. The third position is going to be 8, 6, 7. The fourth position, you can see that this is tedious. This is not how I ought to be doing it. 8, 6, 7, 5. Why don't I stop there? We get the idea from that. So there we go. We have 10 spaces on our data, and we have put good data into 4 of them. This is what's known as a partially filled array. A partially filled array is one where you've allocated a lot of space, but you've only used some of it. Why does that matter? Well, what if these were test scores and we were averaging them? We only have 4 test scores, unless the user actually made zeros, So we would not want to add up all of these scores and divide by 10 when there were only 4 test scores to begin with. We would have only wanted to divide by 4. So if you have a partially filled array, you need to keep track of how many data elements are in it. And you can do something like that. This. I'm going to make a variable called last, and I'm going to set it equal to 0. And each time I copy a value into my array, I'm going to do this. Last plus plus is equal to, and somebody come up with another number to put in here. Maybe just 6543. So that's a 6. And then I'm going to copy this statement. 6543. I've still only got 4 pieces of data in it because I started writing to it at position 0. But I now have something here, which is my counter, to tell me how many values I have. So I'm not going to hard code this to 10 anymore. I'm just going to say go until my last piece of data. And it wrote out only 4 pieces of data. So if you have a partially filled array, you need to keep track of how many pieces of data are valid.
If you do have an array, do you always have to specify how the length of it?
Yep, that's one of the quirks of Java and C++, is that you have to define in advance how big your array is. And that's as opposed to lists in Python. Now there are other classes that allow you to just add them on and you don't declare size to begin with. It's called array list in Java. It's called a vector in C++, and that way you don't have to declare size. But now that I've declared this as a size of 10, I better not write 11 elements to it. It'll write past the end of the array.
And then you
Does
have
it throw an
that
error, or
sitting
does
in
it
the-
just stay in the buffer?
it's sitting in the buffer. Right?
It'll write to it, and whatever was stored after the array might get overwritten. It's possible if it is compiled in debug mode that it'll tell you. If it wasn't compiled in debug mode, it's just going to happily keep running, and you're going to have corrupted data.
Okay.
So C++ is really primitive with respect to its array handling capabilities. Why do I say that? There's no way to query this array to find out that it has 10 items stored in it. And that's unlike Java, where in Java you can call .length, I believe,
Yep.
or is it .size, I forget which. It'll tell you how many items are in it. If you want to know the size of an array, this usually works. Int num elements is equal to the size of the array itself divided by the size of the first element in the array. That should work. What this is saying is I'm going to get the size in bytes of this array. Each int is 4 bytes, as I recall. So 10 bytes, or 10 ints of length 4 is going to be 40. So size of AX is 40, but the size of an individual int is 4. 40 divided by 4 is 10.
Oh, okay.
Great, this works. But this only works if you're in the same piece of code that allocated the array. If you pass in the array as an argument to a function, for some reason this is not reliable and you can't do that. So what you really wind up doing in C++ that you don't necessarily have to do elsewhere is you define your array size as a constant. Constant int array size is equal to 10, and then you declare your array to that size. And then if you ever need to specify a limit to your array, you pass that number around. If you have a function that's going to iterate through the array, not only do you pass the array in, but you pass in array size, and you set that function up to count through that. So an array is like a series of boxes in which you can put data. If you want to, you can initialize it with better data than that. What do I mean by that? Suppose I'm going to declare an array of strings called colors. I want 4 colors in it. And then I can initialize it like this. Red, blue, green, yellow. If I step through the array now, colors at index 0 is red. Colors at index blue is 1. Colors at index 2 is green. And at index 3 is yellow. So item 0, item 1, item 2, item 3. Will this even compile anymore, or have I totally broken it? Yeah. Okay. I don't know how much further to go talking about arrays without actually hitting a PowerPoint for it. An array is a contiguous series of spaces to hold data. It can be an array of strings, it can be an array of doubles, it can be an array of longs, it can be an array of floats, bools, but once you pick a type, that's all that can be stored in it. And for y'all programmers who've taken a Python class, it's quite different than Python lists, where you can create a list and you can store anything in that list that you want. In Java and in this language, once you create an array as an int, that's all you can store in it. You can't store doubles in it. You can't store floats in it. You can't store longs. You just store it, you know.
Does C++ have dictionaries?
Yeah, yeah, it's one of the classes. I don't remember its name right offhand. Okay, so let's write a little loop that's going to print out all 4 colors. There is a special syntax for the for statement that'll just iterate through the array. For every string X that's in the colors array, cout X. And if you ask me, I don't know how that works because I don't know how it's calculating the length of the array. But what that means is it iterates through the loop. The first time X is equal to red, the second time X is equal to blue, the third time X is equal to green, the fourth time X is equal to yellow. I'm going to put a system pause there just so I can see it print those 4 things out. Yep, red, blue, green, yellow. If you were not going to use that specialized syntax, you'd have to have a counter. Like this. For, I'm going to use I for index. For I is equal to 0, I is less than 4. Why? Because 4 is the length of the array. I++, cout my array, colors array at that index, followed by ENDL. And then I need, nope, I don't need to increment I because I'm using a for loop. Two ways of iterating through the loop. This one's cleaner, and I like it because I didn't have to know the size of the array. Here I hard-coded the array to be 4 elements long. Remind me if you can do that. Yeah. If you don't want to specify a length of the array, but you're using an initializer list like that, you can do so. You can say, okay, I don't really know how many I need, but make it that many. The problem with that is you don't have any idea of the size whatsoever, and you're going to have to pull this kind of stunt like we were seeing wherever I wrote it to figure out the number of elements in the array.
So could you
So
possibly...
what do you just, after that, you just print non-elements and then it'll tell you the number?
Well, if you use the first style for loop, then it doesn't matter. It knows when to stop.
So could you possibly, I guess, make like a array, but make it characters, and since you don't have to specify, well, but aren't you still specifying how many elements are in that array? Because, okay, so what if you
Well,
take
we're
the
not
array-
specifying the number of elements,
okay,
but
so
we're
if you take
giving
that
it a,
out, it still works?
yeah, we're giving,
Okay.
we're initializing it with 4 values, and so it knows. If you give this a larger value than what you fill up, then the rest of them are filled up with nulls or zeros. So that's saying I want an array that's 10 long, but I'm only filling in the first 4 values. If you leave that out, it allocates it to the exact size of your initializer list. You still cannot go past the end of it. If I tried to access element number 4, 5, 6, or 7, I'm going to get an error. Let's see if the debugger will catch that. This array is only 4 elements long. I'm going to put that back in there. So we can only access elements 0, 1, 2, and 3. Let's try to access element number 5, or the one in the 5th position, which is at colors 4. Purple, single equal sign. It didn't complain. But it could have. Let's write a while loop that's just going to keep writing past the end of the array. So int I is equal to 0, while I is less than 100,000 or a million, whatever that is. Set colors at I equal to purple. This should totally do something bad. We've only allocated an array of 4 length, and we're writing 1 million elements into it. Let's write something out as we are doing that so that we know it's doing something. Let's see out both I followed by the value that we just wrote to it. Thanks. Alrighty, there we go. Oh, for Pete's sake. I told you I like for loops better. Okay, there we go. It blew up. Unhandled exception. Access violation, writing location. Nowadays, Windows, well, Visual Studio is the one who caught it this time. If we had compiled it for release mode rather than for debug mode, then the error would not have been caught by Visual Studio. It would have been up to Windows to figure out when we were writing, out of into some memory that we should not be writing to. In old days, programs did not protect, or the operating system did not prevent programs from writing into each other's memory. If you were running 2 different apps, then one of them could accidentally go and corrupt the data of the other app. That's supposed to be impossible in modern operating systems. I'm not saying it is, but Chrome should not be able to go and corrupt Firefox's data. So I'm not saying it can't happen, but they're supposed to be walled off. And also nowadays, when programs run, where they run in memory is randomized, so that you can't always just predict where a specific program is going to be stored in memory based on the order of the programs that were launched. And it used to be that you could, and you would know that on Windows of this particular version, the file operating system drivers were loaded at this particular memory address, and so your virus could go and write directly to memory there and reprogram, what that file driver was supposed to do. But nowadays they're loaded into random parts of memory, so an external program can't just randomly pick out, which program. It doesn't know where the memory is. Okay, string arrays. You were asking in a way about this, I think. I want an array called name, and I want it to hold my name. That is how you did strings before C++ was invented.
Before strings?
Yeah, before the string class was invented. That is what people called a string. This is character 0, that's character 1, that's character 2, that's character 3, and an invisible character, which is a null, is character 4. So that's called a null terminated string.
So
And
If you put a space in, would it accept the space as a character?
yeah, that's a 32, I believe, an ASCII 32. Let's print out I'm going to get rid of this code that caused it to crash. For int I is equal to 0, I is less than, I don't know, let's say 10. I++. Let's print out the character value of I. I'm going to cast I to a character. And then let's find out what the string at position I contains. So we should see it say 0, 1, 2, 3, 4, 5, you know, along with the data that's stored in it. And I also want the ASCII value of it. Okay, so that is the number of it, that is the value of it, and let's get the ASCII value of it. So that'll be the int version of that character. So this is the index, this is the character at that index. That char right there is wrong. I don't know why I did that. There we go. And then this is the ASCII value of that char. What we should see is JEFF followed by a 0 followed by whatever the rest of this string has been initialized with. I can't predict what that is. Did we not end our program? Try again. Alright, so there's my name. JEFF, a capital J if we went to the ASCII chart is a 74. And E is a 101, and an F is a 102, and another F is a 102, and then that string was terminated with a 0. And apparently the rest of that 80 spaces, 80 characters, is also filled with zeros. So when you took computer science classes in the 70s and the 80s, you learned a lot about manipulating strings. Like if you wanted to get only the first 4 characters of it, how you would get those and put them into another thing. Or if you wanted to extract the 71st through the 90th character, what kind of loop you'd use to pull that out.
So essentially when you're calling a string in C++, it's actually an array.
There is an array built into that string class.
That's what the class is. In the
It's
C++
a wrapper.
is.
Yeah, the class has some data in it, which is that array of characters, and then it's got some extra functions to make it more useful.
Okay.
And so that's your general definition of a class.
That's
Is a
weird
class has
that
got
it's-
data, and then it's got functions that modify that data.
It's weird to think though that a class that we're using all the time was something that we just didn't have.
Right, yeah. All right, I think that's enough. Let's stop. Hammer time.